Hey y'all, it's me, Miss B, and today we're talking about writing and evaluating logarithmic functions. So this first note here is that logarithmic and exponential functions are inverses of one another. But what does that really mean? I'm going to show you with a Desmos. So what I have graphed here is I have 2 to the x in the red. So this is a function 2 to the x. And if I were to have a line x, so it's splitting x and y, it's going directly diagonal. If I were to reflect this 2 to the x over and get this thing in the blue here, you'll see that that is an exact reflection, which is the log base 2 of x in the blue. So that's what it means. It means it gets reflected over that line, y equals x. So x becomes y becomes x. So flipped over y equals x line. That's what that means. Okay, and so with that domain and range flip-flop, we're not going to worry about that too much. So if I have this right here, that's read as f of x is equal to log base a of x. Log base a of x. All right, and then we have this thing called e. If we have a base of e, then log base e of x is equal to ln of x. And I do like to write log and ln in cursive just so that it doesn't look like one n. Okay, so we are focusing, if you remember, on writing logarithmic functions. So this is the writing of it. If we have something in exponential form, notice over here I have b, e, and a. So if I have an exponential function, it has a base, then it has an exponent, and that gives me some kind of answer. Okay, so b to the e equals a. So an example of that would be 3 to the 4th, well, let's do 3 to the 2 equals 9. Okay, in logarithmic form, let me actually color coordinate this here. So that's 3 to the 2 equals 9. And then in logarithmic form, what I do is I write it as log base b of a equals e. Okay, so I have bay. Okay, so that's what I just bay it. Okay, so with this example, the way I would rewrite it is I would have log base 3. Again, I write that in cursive of 9 equals 2. So that is how you'd arrange between the two. Hopefully the color coordinating there does help you see that a little bit better. Okay. So we're going to switch these back and forth. So I've got a few examples here. Notice that this is 2 equals log base 5 of x. I'm not used to seeing it in that way, so I'm actually going to rewrite it as log, again, cursive, log base 5 of x equals 2. That way, I can easily bay it, because this is my b, a, let me write in capitals here. Ooh. This is my b, a, and e. So it's already in bay, so I need to put it in the other form. So 5 to the 2 equals x. So I unbayed it. So this is my base exponent answer. Okay, next one here. Again, I'm just going to take this over to this side. That way we can easily see the function there. So then this is my b, a, e, and I'm going to switch it over. So I have base exponent answer. Oh, I guess I should have written that on the line. Just like that. Okay. Save this last one for you to do. What you should have got was 3 to the y equals 7. All right, let's go the other way. So this is my base exponent answer. So I'm going to bay it. So I have log base 12 of x equals, that's an ugly x, of x equals 2. It's log B-A-E, bay. All right, this next one here, here's my base exponent answer. So we have, this is going to be log base b of 8 equals 3. Finally, I'm going to leave this last one for you. Okay, so for this one here, this is my B, E, A. So I'm going to bay it. So I have log base E of 9 equals y. However, when I have log base E, you have to remember from before, log base E is equal to ln. So I can change this to ln of 9 equals y. Well, let me color coordinate there. ln of 9 equals y. So that is what our answer is there. Okay. Saving those ones for later. Okay. Now we want to be able to evaluate without a calculator, which is why we're switching back and forth. So for this one here, I have log base 2 of 16 equals x. So I have, this is my base answer exponent, so I do base exponent equals my answer. So this is where this comes in, and I ask myself, 2 to the what equals 16? So 2 to the what equals 16? You can easily answer that as 4. So 2 to the 4th is equal to 16. So x equals 4. All right, go ahead and try this next one on your own. Start out by rewriting as 3 to the x equals 27. Then you ask 3 to the what is equal to 27? And 3 to the 3rd is 27. So x equals 3. Okay. So, this one here, this one we're evaluating with a calculator. And so you'll notice that this is, if this log is written without a base, so this one has no base on it, it's assumed or implied that the base is 10. So this is the same thing as log base 10 of 150. And you can just type log of 150 in your calculator. Go ahead and turn these off. So you just type log and 150, and it gives us 2.176, so 2.18. So this is 2.18. Okay? Go ahead and type these ones into your calculator. For log of 3, you should have got 0.48 rounded to the nearest 10th or 100th. For log base 9, you should have got 0.95. And for log of 70, you should have got 1.2. 0.85. All right, and that's all for today, folks.